Okay, so hello everyone. The question which we are going to solve is day before yesterday's POTD. Okay, in this question, which apply operations to maximize score. See, in this video, we are going to talk more about the intuition part, right? Because the coding part is it's the coding part isn't tough, right? If you have the intuition, then the coding isn't that tough, right? So here we are going to talk more about the intuition. Okay, so the question number is 2818, and as you can see, it is marked as an Arduino, right? Okay, so let me just read the description and then we will try to solve it. So you are given an array nums of n positive integers and an integer k. Initially, you start with a score of 1, right? Okay. You have to maximize your score by applying the following operations at most k times. Okay. Let's see what the operations are. Choose an non-empty subarray nums which starts from L to R that you haven't chosen previously. Choose an element x of like uh, nums of L to R with the highest prime score. If such multiple elements exist, choose the one with the smallest index. Okay. Multiply your score by x. Here, the nums L to R denotes the subarray of nums starting at index L and ending at index R, both ends being inclusive. It means that L and R are the actual indexes. Doesn't mean like L minus 1 or R minus 1 or something like that. Okay. The prime score of integer x is equal to the number of distinct prime factor of x. For example, the prime score of 300 is 3. Why? Because as you can see, this is the prime factorization and it has only 3 distinct integers, right? Okay. Return the maximum possible score after applying at most k operations. The answer may be large, return it modulo 10 raised to power 9 plus 7, which we can also write it like 4139 plus 7. Okay, okay. So, this is the question, right? Let's just take an example. Okay, let me just take this example. Which 1, 12, 14, 6, 10, 8, like 19, 12, 14, 6, 10, 14, 6, 10, and 8. Right? And we have k equals to 3. So let me just write the prime scores of these elements. So the prime scores are going to be 1 scores are 1, 2, 2, 2, 2, and 2. And the uh, initial score is equal to 1. So we need to maximize this score. Okay, so we need to maximize, right? And we have k equals to 3. We can choose a range. Range can be something like this also, like we can tell comma r, this is also a valid range, right? We can choose it, right? We can also choose L and R, but we can also choose L and R. Okay, so the range doesn't have limits. We need to maximize it. So in order to maximize, what we're gonna take, we just also write their indexes 0, 1, 2, 3, 4, and 5. To maximize a score, we should be taking the maximum element, right? Okay, let's just take it. So, which is the maximum? Active. So the score becomes 1 into 19, which is 19, right? Then we need to maximize, right? So what element should we take? Can we take 18? Probably we can, because like then L comma R, right? So we take 18 into 8, right? So what will be our answer? Let me just calculate it. 9 into 18. So 8 nines are this 72. 8 was 8 plus 7, which is 15 into 19. So 2 9 plus 1, which is 14. This is 3. So 2, right? Here, 342. Okay. So now, what element should we choose? We should be choosing the next greater element, which is 40, right? So we go to 40. Okay, let me just increase the value of k. Okay, the k, let's suppose it's 4. Okay, now things will be clear. So we choose the 40. So the score becomes 342 into 40. Okay, let me just 342, 342 into 40. So 4 twos are 8, 4 twos are 16, 4 threes are 12 plus 1, which is 13 into 2, 4, 3, which is 8. 6 plus 2 is 8, 4 plus 3 is 7, and 4, 7, 8, 8. Right? If our k was equal to 3, this would be our answer. Right? 4, 7, 8, 8, 4, 7, 8, 8. Right? I should have also decreased the value of k. So it will become 3. Okay. When it was 4, we got like for 4, we got the answer 19. Then for 3 and 2. Okay. So for this we got 342, and for this we got 4788, and we have still 1k left, right? Okay. So what would be the answer? Okay. We have taken 40, so we should be taking the next greater element, right? And which is 12, right? 12. So 4788 into 12. We just do it. Okay. 4788 into 12. 4788 into 12. 8 6 6 8 to the 16. 16 plus 1 17. 17 to the 14 plus 1 15 and 4 to the 8 plus 1 9 into 8 8 7 4. We just sum it up, so this becomes 6. 7 plus 8 becomes 15. 15 comes here. 8 plus 6 is 14, and we have 17 here, and we have 5. Okay, so 5 7 4 5 6. Okay, so this will be our answer, right? No, no. We were going right. We were right at this step, and this step, but we are wrong here. Let me show you why. See, for 19, tell me one thing, that 19, and we can take 19. Can we again take 19? Wait, what? Can we again take this 19? How we gonna know? We can know. Like, which color should I use? Basis. Can we take this 19 again? See, read the question again. Choose an non-empty subarray nums this that you haven't chosen previously. Choose an element X of this range with the highest prime score. Okay. Suppose we want to choose again, like let's just suppose we have taken this subarray. Now we are taking this subarray. Tell me one thing, that can we choose ID? No. Why? Because 12 has a better prime score, so we need to choose that. Okay. Can we choose this prime score? Like this subarray? No. Again, the prime score, right? Can we choose this? No. Can we choose this? No. Can we choose this? No, because these all have a better prime score. So 19 can't be chosen again. Okay, so 19 was a valid one. Okay, then we choose 18. We have chosen 18, like this array. Okay, so can we choose, like, okay, so suppose this step is also a better one, like the correct one. Okay. Tell me one thing, that can we choose this 18 again? What are its subarrays? This one. Can tell me one thing, that can we choose 18? No. But why? 18 is greater. Yes, but it has a lesser see. Can we choose 18 in this array? No. Why? It has the same prime score. Okay. 18 is greater also, right? Okay. But why not 18? Because of the index. See here. If with the highest prime score, if multiple such element exists, choose the one with the smallest index. In this case, the index of 15 is greater. So we can't choose 18 here. Can we choose it here? No. Can we choose it here? No. Can we choose it here? So 18 1 was also the right step. Okay. Then for 14, why it's okay. So 14 we choose because like we choose the same this subarray and the 14 was correct. Okay, so we are corrected here. Now what did we choose? We choose 12. Okay, but we could have also chosen this subarray and the 14 we can get again. Wait, what? If we chose this subarray, we could have get the 14 again, right? I'm not talking about this one. Neither I'm talking about this one. I am talking about this one, and this one. In these cases, we could have chosen the 14 again because they have the same time score and the 14s and like the 14 have the lesser index. Okay, so what I'm telling you to say here is that you could have choose 14 one like 1, 2, 3, 4. You could have choose 14 4 times, but you only choose it once, and you got the wrong answer. So can I say that see, you can only 19 will only be dominant in one in one scenario. Okay, 18 will also be dominant in one scenario, right? This 14 is dominant in four subarrays. Okay, what about 6? 6 you can choose here, this subarray, right? So 6 you can choose this subarray, and this subarray. 16 is dominant in 3 subarrays, and 10 would be dominant in only 2 subarrays, right? 1 and 2. Okay, so tell me in like how many times 12 will be dominant? 12 will be dominant in this subarray, this subarray, this subarray, this subarray, this subarray, and this subarray, this subarray. So I think you got my point. We can choose an element like the number of times it's dominant, right? I think you get my point. So how many elements are here? Like 1, 2, 3, 4, and 5. Okay, so I think that it's dominant in 10, and this is dominant in 1. Okay, so okay, see what are the observations here. The first observation is like the first thing which we need to do is find the primary scope. Find out in how many sub-array sub-arrays number is dominant. What is this dominance? Dominance means that in how many sub-arrays you will have the priority, or you will be dominant in those many sub-arrays. That's what the dominant means here. Okay, it's not included in the question, but I am saying it as a dominant because it is dominating in sub-arrays to some. So how can we dominate? Like how we can find out the dominance? Like and the based on dominance, see things are like a very clear, might be very clear to you. The first priority, let me just write it down. The first priority is primary school. The second priority, or like I think that it's the first priority is in the primary school, right? The first priority is greater element, greater element. The second, if like the first priority is a greater element, right? Okay, and second, I would say like dominance. In how many seven is its dominant, right? Okay, like it's not a priority, it's a condition, right? Okay. The second priority is a prime score, and the third, if they have same prime score, it's what? It's index, right? And we should also be having a condition in which we will be having a dominant, like we know that how many times we can choose a number based on its dominance, right? So see what we can choose. We can clearly use a priority queue or a heap, right? In which we will be having custom comparators and all. Okay, like this field should be maximum. This should also be like, maximum, I guess. Primary score should be like more of it. Index should be minimum. Dominance doesn't matter, so like it does matter for like how many channels you can choose, but this is what it will something. So how can you find the dominant? Dominant is based on where should I be writing it? You just write it. Dominance is based on prime score. Let me just write down the like what 19, 12, 14, 6, 10. Okay, so let me just see if I can copy it. Or let me just dominance is based on this. Okay, so the number is 19, 12, 14, 6, 10, and 18. 14, 6, 10, and 18. 14, 6, 10, and 18. Right? This is 0, 1, 2, 3, 4, and 5. And their prime scores are like the, let me just write it as a PS, which is 1, 2, 2, 2, 2, 2. Right? Okay. Okay. Let's see that you might have solved a question related to stack in which we find next greater element, previous greater element, next smaller element, and next greater element. oh, previous small element, next small element, and previous small element. You might be knowing this, so that's what we are going to use here. So let me just find out first the next greater element. So let me just rub it off. So this will be okay. So we are here. Tell me one thing, that how many, at what index the like uh, what index has a greater primary score? There is nothing. So what we are gonna write is 6, right? Similarly, for this 4, tell me which index has a greater primary score. No, 6. Again, for this one, same thing, right? Because no element is greater on no element on the right hand side is greater than 2. So we are gonna write 6 again and 6 again. And here what we are gonna write? We are gonna write 1. Why? Because at 1th index we have a greater primary score. Okay, okay. So I think we're getting it a bit. Okay, so now we can find out the previous greatest element. Previous greater element. Okay? I think it as PGE, right? So now tell me at like we're standing here. So tell me at which index we have a previous greater element. -1, because we don't have a, like, 1 doesn't have a previous greater element, but this 2 previous greater element, or see, NGE was like checking equality. Here we are gonna check like if it's equal, we are like, see, in this case if it's equal, we gonna equal we gonna consider it. Here, see, why we equal not consider, equal not consider. Here we are not considering the equal elements, right? Because for like this we have taken 6, we didn't consider this too, but in this we are going to consider. Why? Because see, standing at this point, whatever are equal, we won't consider it because this is the dominant one, right? Because of its index. And if we check in the previous ones, if it's equal, it won't be dominant, right? So if it's equal, we are gonna consider it. In this case, see, you need to do the tyrant for it. Okay, you like have to do it, otherwise you won't be getting it, right? Why? We, like, for this case, we didn't consider any equals, right? Because of its index, we know that if the primes will be equal, this will be the dominant one because of its index. But in this case, if we're going to look backwards and see, if any element is equal to this element, this won't be dominant because of its index. So in this case, we are going to consider the indexes, right? So for this one, we have, do we have any previous or greater element? No. So this will be -1. Okay. For this 40, like index 2, is there any previous or equal element? Yes. Consider it. 1, 1. Consider it. Then 2, 3, and 4. Okay, so we need to calculate the dominance. Okay, if like the forward element which has the same prime score, this element will be dominant, and if there is previous element which is equal to this won't be the dominant one, right? Okay, so now we can calculate the dominance. How? This element, uh, like suppose there is an element and there is something left and y. So x and y. So x into y will be our dominance, right? So like I should be considering it, right? So let me just copy down the NG and PG, then we can calculate the dominance. See, the question is purely based off observation, right? So I think I should copy it and then I should be pasting it. Okay. We have a NG and let me just also copy the PG. Okay. And let me just also do the indexing here. So it is 0, 1, 2, 3, 4, and 5. So like dominant, dominant. So 1 minus 0 into like if I calculate it like NGE like NGE minus I. Where should I write it? Let me just write it down here. So NGE minus I into I minus PGE will give us our dominant. Dominant. Right. Right. So what should I be writing here? It would be NGE is 6 minus I, which is 5 into like I, which is 1 minus 1, which is 2, so this will be 10. And in this case, 5 into 1, which is 5. No, it will be 6 minus 2, which is 4, and 4 into I, which is 2 minus 1. So it will be dominant in 4, this will be dominant in 3, this will be dominant in 2, and this will be dominant in 1. Right? So we have our dominance here. Okay. So let me just do the try run for this particular case and then we will be good to go. Okay. So for like we have taken the k equals to 3 here, right? K equals to 3. So what our priority queue will be looking like? Okay. We would be having like 90 comma what is dominant, its prime score, its index we are checking, and we will be having a dominant which is 1, right? Then we would be having 18, and after 18 we'll be having 5. Okay, no, its prime which is 2. The index is 5, and its dominant which is 1. Then we will be considering 14, 14 comma 2 comma 1. It's 2, and it's dominant 4 times. First, let me just, okay. So first, this will be considered at k equals to 3, and this will pop out because its dominance is over. Then k equals to 2, this will pop out because its dominance will be over. This at k equals to 1, and this will become 3, and this will still remain in the priority queue. Because like suppose there is a k equal to 0, or then we will be considering this, then again, so it will be dominant 4 times, right? Okay, so see, like I think the video is quite long. Okay. So this is what, how we going to do it. So I think that like let me just show you the code. The code link will be in the description, but I think that you should be doing it, okay? Because like the code is quite long. It involves multiple concepts. It involves multiple techniques, which I can't like cover in a single video, right? Because there's prime check, there's like ng pg, there is also like priority queue use, there's a comparator, and like the question involves multiple things. So let me just show you, but I think you should do it once. Here we have a custom comparator, right? This one checks the prime score. Okay, the code will be in the description, so you can check it out. This will be prime score, right? And like there we have a next greater function, there's a previous greater function, we have a mod like for exponential, exponential to calculate the result. Okay, so this is how the code is looking, right? Oh, and like we have a priority queue, calculating okay, so this is here. Okay, so at last we are just running this code. Okay, so the code will be running just fine. Okay, so I think that you should be studying the topics involved in it. Okay, okay, so like, what is involved in this? Let me just write it down, and then you can check it out. Okay, so okay, so what's involved in this that you should be studying is prime score, in which you will need to know CVOP, derivatives, those I guess like it's like that. The spelling might be wrong, but I'm telling you the topics. You should be knowing how to find, how to find, like where's my pen? Next greater element, previous greater element, And the third thing is fast exponential, right? So, like this exponent, okay, so exponent, okay, so multiplication. So these all are the topics you should know to in order to solve it. And yeah, there's also priority queue. How can I miss that? That's the main priority queue. Okay, queue, which is heat. Okay, so these all are the topics which you should be knowing in order to solve this question. And I think that you should be solving it, because if you solve it, what you are going to cover. If you know this, you will revise it once, like you will have a better practice on it. If you know it, like if see, if you know these topics, then it's a good way to practice it, and if you don't, then it's a good way of learning it, right? Okay. So yeah, thank you everyone. Like that's all for this question. Have a nice day ahead. And the question and like the code link will be in the description box. Okay, so there you can check it out. So yeah, thank you everyone. Have a nice day.